Alright, so what we developed here is a vehicle security system, which essentially has three components: the hardware, physical server, and the cloud server. To start, I'll begin with the hardware section. With the hardware, what we do is we've integrated a bunch of sensors and modules onto the actual vehicle so that we can take in data and process it using an algorithm. What we want to do is, rather than having a passive system, we've developed an active system that tries to predict what's happening. So rather than if a mother has a stroller passing by the vehicle, we don't want the alarm to actually go off. We want to know that she's not posing a threat. So that's what our algorithm tries to do. The data that's captured here is packaged, and we try and transmit it through the Wi-Fi module here. The Wi-Fi module uses an AT command set, which is the same command set that GSM modules use. So it's very simple to switch over to the GSM module, but for this application, we just simulate it with Wi-Fi, so we wouldn't have to pay for the SIM card. So once we package that data, we send it across to a physical server, which is a computer. So in this case, we've decided to go with the computer for demonstration purposes, so you can see what each part looks like, but in the actual physical vehicle, this would be a controller. So what happens is this TCP application pushes the data that we've captured from the microcontroller down to a Ruby application. This Ruby application then takes this data and posts it on the web application that we've developed. So I'm going to let Nassim take over and explain the web application.
Right, so the communication between the hardware to physical server and physical server to cloud server, they share a common text file on the physical server. So just to demonstrate any changes that are done on the physical server, which would come from the microcontroller, but to demonstrate I can show, I'll make a couple of changes to the values here. So for instance, if I change the danger, if I activate the alarm, and if I change the location. So once I make these changes, they then get updated to our website where users can go to track the condition of their vehicle. So you'll see, there you go. So 3:20 p.m., and we have a couple updates that have just come in, which consists of the new location updated on the map, the new danger level, and that the alarm has been activated. So you'll see I just got a text message as well on my phone, and the text message you'll see states 3:20 p.m. the alarm on your vehicle has been activated. So instant text message. Oh, here we go.
I can't take it. But anyway.
Try moving it further away.
Here?
No?
Is that okay? So you'll see it's synchronized. The same time as the events came to the log, you get the update of the text message informing you of the condition of your vehicle.
So we had two goals here. The first goal was on the hardware side, which was to add that level of intelligence to our system. And the second goal we had was to have available a way of interacting with the alarm no matter where you are on any device that's connected to the internet. Whether it be your iPad or your laptop at home or at work, it doesn't matter where you are, you can connect to this application and see the data. So now if we move to the actual hardware here, so what we developed is we're using an M4 Cortex, which is on the STM3240G EVIL board. That's a pretty long name. Sorry, to set off the alarm. So as you can see, what happened was I was standing in front of this sensor, and after a certain amount of time, it knew that I was here, and it turned the motor, the camera, to my location to take a picture of my face and upload that onto the server. So I'm going to turn that off right now. I don't want to set it off again, so I'll step back. So now, what it does is the algorithm will do a 4-foot range.
So you get 3:22 p.m. The alarm on your vehicle has been activated. So Ryan just set off the alarm and we got another text message.
Okay.
So what our algorithm does is, for this simulation, we're doing 4 feet. So we want to try and scale things, and we also kind of want to predict vectors that people are taking. So if I'm walking by the vehicle versus if I'm walking towards the vehicle, I want to know that. So what we use is differentials, so previous values and current values, to try and determine what people are doing. If I was just standing here, then further away, the alarm system might play the message. So, pair of batteries died, but it would play a message saying, please step away from the vehicle. If I continue to stand there, then the alarm will actually activate. And it's a pretty big project, but it was lots of fun.